Okay, so what's this, 2.7, number 9? Okay, I'll give you a heads up on this one, give you a start. So the question says, suppose f is this function and laid out like this. So this is the expression. We've got f of x in there. We've got obvious kind of chain rule. We've got power rule going on here. Remember, f of x is the same as y. So the givens over here are f of 2 equals 1. So that means that x equals 2 and y equals 1, if that, if that helps. And then f prime of 2 is what we want to find. So we want to find the derivative of x, the derivative of f, and then plug 2 in. So let's just see kind of how it goes here. This one, f times f of x cubed, that's going to be a power rule and implicit, right? This is implicit differentiation. So the derivative of the first is 1 times, because it's x, times, what's it, f, times f of x cubed. Okay, now remember that's y cubed, right? So here's y. So that's going to be later. Derivative of the first times the second plus the first times the derivative of the second. Now this is going to be 2 f of x, sorry, 3 f of x squared times f prime of x, chain rule. Okay, so we did product rule with this one. This whole thing is the product rule for the first one, right? Derivative of the first times the second plus the first times the derivative of the second with the chain rule and everything in there, okay? Now I'll change colors here. So now we're going to do plus the derivative of the first is 2x times the second plus the first times the derivative of the second, which is f prime of x, equals 0. Just bring this down a bit. Okay, and the blue is the second part there. There. Does that make sense?
Yeah.
Okay. So when we get to this point, it's like, well, that's a mess of stuff. Okay, well, we're gonna try and we need to solve for this, right? Like, so we can plug some things in first, maybe to simplify things, but you have to kind of isolate f prime of x, I guess, right? So let's just see what happens here. Again, this is 1 times f of x, which is, f of x is, well, if we're talking about 2, so we're looking for at x equals 2, right? So f of x, when f is 2, is 1. So this is actually 1, this one, times 1 cubed. X, right here, in this situation, at this moment in time, is 2.
Yeah.
So this is 2 times 3 times. Now this is just a regular old f of x, right? Which is 1 times, now this is going to be f prime of 2 because we put 2 in everywhere else. So again, this is one of the things we're going to be looking to solve for. 2 times x is 2 in this instant. Y, or f of x is 1. X is 2, so that's 2 squared times f prime of 2 equals 0. So I'll leave that now with you. This should be pretty easy now. We're going to have to factor an f prime of 2 out of these two terms. Everything else here, this and this, has to go to the other side. Factor an f prime of 2 out, done. Okay? So I'll let you guys do the rest because I don't want to do the whole question for you. I just did 90% of the question. Okay, so go ahead and finish that. So the answer should be -1/2, but like I say, the textbook solution manual that you may be referring to just does things a little backwards. I always do the derivative of the first times the second first. They do that second, so they list that second. It's addition, doesn't matter. Yeah, it doesn't matter. You're right. So anyway, so you should end up with -1/2. And again, we plugged values in before we simplified and solved. They simplified, condensed things, then put the solutions or the numbers in right at the very end, which you don't have to do. You can put the numbers in first. So -1/2 is kind of the two different ways to do that. Got it? Yes, no? This is a very good AP question, like I said, good AP practice question. You will have questions like this, where you will be given info just like this. So this is like almost exactly an AP question that I've seen on many practice exams. Or you'll be given a graph, right, where the graph says that x equals 2, y equals 1. And then you'll be able to calculate the slope of the tangent line or whatever at a certain point to find other things. So anyways, it's a good question. A challenging one, but it's a good question.